Hello friends, very good morning to all of you. So today we are going to discuss PF07, that is Introduction to SSO High Level Architecture Diagram. So we'll just try to cover the on-premise as well as the cloud. So in PF06, like we cover the different components, right? Like whatever we used in the on-premise as well as in cloud. So we'll just try to draw that and we'll just try to understand that how basically the SSO architecture looks, right, and how the things are flowing. So in I'll just try to make this in two parts to make the videos shorter, right? So in first part I'll just cover the on-premise, and on the second part we'll just discuss on the cloud part. Yeah, so let's begin. Yeah, so let's try to understand that the on-premise model, okay, of the SSO architecture. So yeah, let me open this app.diagrams.net where we'll try to draw something and it will help you to understand. So yeah, this is a good tool, right, where you can use to make some architecture diagram. Okay, it's a good thing. So maybe you can just yeah, make a note of this also. So first of all, let me make a size 80%. Okay, so now let's understand like how the architecture basically flow, right, like, or how the architecture is built. We'll just try to understand. Maybe I'll not cover the smaller and smaller things, yeah, but I'll just try to give you a very good idea of the architecture, so that like at least you understand, like if someone can give you a diagram, right, at least you understand, okay, this is the flow and this is flowing, and maybe you can just understand and you can just help the team also in troubleshooting the problems, right? So let's see, let's draw the user first. Okay, so I'll put it user here. This is an internet user. Okay, we'll mention this as an internet user, like make it as a internet user. Okay, that means the user is basically coming from the internet, right? So we'll just try to understand, like if a user try to access federation based application from internet, then how the traffic will flow, and same we'll try to understand from the intranet. That means if the user is present in the client network, in that case, yeah, like, or maybe you can say client network or company network, in that case how the flow is going to happen. Okay, how that user can reach to the authentication server and get authentication, and then finally able to access the application using single sign-on. Okay, so now internet user. Okay, now first of all, like if internet user will try to access, just imagine that internet user, that you are a user coming from the internet and then try to access some SSO based application, federation based application. Now first of all, what will happen here, this request, okay, first of all this request will go to, mention this as a, this will be the public DNS. Okay, so you can see that, like whenever you just build the architecture, right, you have the two DNS, right, because like to handle the traffic, right, because yeah, people can access the application from internet as well as from the intranet. So you have the two DNS, like public DNS and the private DNS, or you can say like, yeah, like yeah, you can put a name like external DNS, internal DNS, like that. Okay, so I'm putting as a public DNS for now. So first it will resolve to the public DNS. Now from public DNS it will just go to, in the cloud when we will talk in the next part, like I'll just talk about the AWS only. So in that we have the something called as a PHS, public hosted zone, which basically responsible for the traffic routing, right, how the traffic is going to route. So in the similar way here in the on-premise we have, let me draw this. So I'll make it like this. Okay, so we have something called as a I'll mention as a let me put it like this circle. Okay, so this is something called as a Akamai. Okay, so Akamai can work here as a GTM, okay, global traffic manager. So is the responsibility of Akamai is to just help in the routing part, right, as a global traffic manager. So for example, like I'll just show you in this diagram only, like as a high availability, you can see that we are just running the authentication server in two different data centers, right, so that like if one of the data center have any issue, like the load can be shifted to another data center automatically by the F5 load balancer, and the end user will not see any impact. okay, while accessing the applications via single sign-on. So Akamai is responsible here for the global traffic manager, okay, that to basically send you to the nearest data center. For example, if you are accessing an application from India and your data center present in maybe UK, right? So your traffic will go through UK only. But for an example, if you are in US and you have another data center placed in US, that means your traffic will go through the US data center, right? So we'll just try to see here, okay. So now you can just understand that request went to the public DNS, then to Akamai GTM. Now it will go to the load balancer, okay. So let's see, okay. So let me put it like this, okay. I'll just draw something here, okay. Yeah. So now you have, let me search here like of load balancer, okay. It will make our diagram little better, okay. That's why I'm just searching. Okay, so let's take a classic load balancer, okay, not a problem. I'll rotate it. Okay, so this is like a external load balancer, okay, which basically just a second, yeah, sorry for the disturbance. So yeah, like you have now, like as I told, now from Akamai GTM, like it just sent the traffic to the load balancer, okay. Now I'll mention this name as a external load balancer, okay. You can say as external load balancer because here the traffic is coming from the internet, and okay, external load balancer. Now external load balancer has to send the traffic to the server, right, which basically is responsible for the authentication and other things, right. Now when you're coming from the internet, right, from the from the internet side, right, that means you are not coming from a trusted network, right, in that sense I am saying. So in that case, like we are not trying to expose our PingFederate, right, because PingFederate is like a authentication server, right, which basically handles the authentication. So we'll not try to expose PingFederate over to the internet, right, and what we'll try instead of that, we'll just try to put some other layer, right, so that like first the traffic should cross through that layer, then it can come to our PingFederate, right, later. Okay, so in this case, for an example, what you can see here, like you came to this load balancer. Now load balancer will not send the traffic to the PingFederate authentication server, right. Instead of that, what we'll do, we'll just use some Apache, okay, like I'll make something, 1 second, make it a little small, okay. So this is our Apache server, right, which is acting as a reverse proxy. So I'll just make it some 1 or 2, okay, it can be more than that, and same thing we can put it. Okay, like this. So now what will happen, like this is our Apache servers, okay. So I'll just mention this as a Apache servers, okay, which basically just like working as a reverse proxy. That means it's just acting as a it's just create a one layer of security, right, before a user can reach to our original authentication server, I can say in a layman way, right. So that exactly where authentication is going to happen. Now why just I draw this like this, because yeah, as I told that we are working in the high availability mode, right. That means you need to place your nodes, your server node, in 2 different places, so that if one data center is having some issue, another data center can able to handle that, right. So maybe you can imagine that this is one of the data center, okay, and take an example here, like maybe it's a data center placed in Chennai, okay, and this is another data center placed in, maybe you can say, imagine as a Bangalore, okay, Bangalore. So you have 2 data center, Chennai and Bangalore, and you have Apache servers running on both the data center, okay. So you have the Apache servers here, like I can just mention like A1, okay, A2, or maybe I'll mention Apache Chennai, that means AC1, okay, and here I'll mention is a AC2, and here I'll mention as a Apache Bangalore 1, and here I'll mention AB2. C2. Okay, so you have two data center, okay, Chennai and Bangalore. In Chennai you have Apache server running here. In Bangalore also you have running, and the external load balancer has to send the traffic to both the nodes, okay, to the Chennai and the Bangalore, depends on the Akamai global traffic manager. As I told, right, for an example, if you are in Tamil Nadu, right, that means your traffic will go through this Chennai, this node, right. But if you are placed in near Bangalore, then your traffic will go through Bangalore. So it depends on the region wise, right, and that's the work of the Akamai here, the global traffic manager, right. It will handle through that how where the traffic has to route, right, based on your region. Now let me draw this. Okay, I'll just make it something on the second. Yeah. So okay, like this. Let me make it one more. Okay, so you have now the traffic will through Akamai, it will go to the external load balancer, and then it will go to our Apache servers, right, whether Chennai or Bangalore, depends on the region, but it will just land to this node. Okay, now once you reaches to here, your authentication hasn't done, right, it's just a extra layer of security, you can just imagine, right. Now what will happen, let's bring again this. Now let me make it 1 second here. Okay, I'll just make it. So now your traffic has to go to another load balancer, you can see here, right. And whenever you can see the traffic is moving from one place to another, definitely there is some port, right, through which it's communicating, like 443 is the secure port, right, HTTPS. So it's communicate using that, and it depends, like you have, if you open any other port for any other communication, then yeah, it can communicate. But yeah, as you know, in the network, I think if you have some basic idea, so that's the way how the communication is happening, flowing in network, right. Let me make it. Wait, I'll put it like this. Okay, yeah. And now let's bring again our load balancer, application load balancer, you can say as an internal load balancer also this. Okay, so I'll make it name as a, just for a better understanding. We just need to understand the work, right, like exactly how the things are happening, right. Internal load balancer, and here we use like F5 load balancer. Okay, in general people are using that only, it's not like only F5 is providing, but in general people are using that F5 load balancers. Okay, so for example, take an example. Okay, so of F5 only. So now you can see what is happening. Your traffic came to external, then to your Apache servers, and then it coming to the internal load balancer. Now again the same thing will repeat, right, because you see, right, again as a high availability I need to put my authentication server in two different nodes, right. So now you can see here, like you have the original authentication server, right. So let me bring it here, like, okay, make it a small. Let's draw like this. Okay, not a problem. Okay, so this is our original PingFederate now server, right. So again we have the Chennai and Bangalore data center here again, right. So I'll put here like again, like this is our PingFederate. Okay, so I'll put as a PF, this is Chennai, so I'll put C1, and this is PF, PingFederate C2. This is a PingFederate engine node, right. I discussed in that PingFederate, right. So we have engine node and the admin node. So admin node is basically where you're doing the admin stuff, and the engine node is basically which is serving the authentication request coming from the user, right? So here we have the engine node, and engine and admin both are connected again using some port, right? So we'll just in our installation and configuration you'll get a very good idea. And I'll just recommend you also please try this, right? I'm just covering in the video, but you can just try in the similar time. Maybe you can also just set up your lab environment, just do that stuff so that you'll get good confidence, right? So now here I think PF Bangalore 1 and PF, we'll put a name convention, okay, PF Bangalore 2. So you have the PingFederate engine node now in Chennai data center as well as Bangalore. And based on the as I told, right, based on your reason the traffic will route, and here the load balancer is sending the traffic using round robin method. It's a big generic algorithm, right, used for that. So let me bring again that this one, yeah. Okay, so I'll just make it like here and I'll put it here, okay. And similar, okay, maybe this is not correct, looks correct, but yeah, this arrow is need to be pointed, okay, like this, or maybe just understand, yeah, like it's just coming to this data center, okay, or let me try if possible, okay, something like that. And okay, so from internal load balancer traffic is coming to two different data center of PingFederate node here, like on Chennai data center and the Bangalore. And now once the request reaches here, now this is the server which basically where all your policies, everything is written, right? And basically this area is a secured area, right? That means it's present in the private subnet. Like that means that it's from internet you can't directly reach to this private subnet. Like once you have the understanding of basic network thing, so in network there is a terminology called as a NAT, network address translational. So using that only the traffic here is coming from internet to your private subnet area, right? So basically private subnet does not allow access to the internet, right? That means that's why our PingFed, because PingFederate is the server, right, where exactly the authentication is happening. So we are not trying to expose that over to the internet, right? That's why we put it under the private subnet. We have the internal load balancer, and then exactly the authentication happening here, right? So this is the a rough idea you can understand, right? So you came to this area, public DNS, Akamai GTM, then the external load balancer, then the Apache server, then the internal load balancer, then to the PingFederate server, right? And everywhere whenever you see the network is flowing from one place to another, you can definitely, maybe it have some network components, it can be a firewall and all those things, right? So that just to make the things more secure, right? So you need to have understanding on network and the firewall side also to design this architecture, right? If you have a very good understanding on the PingFederate, you can't able to draw the architecture, right? But at least I'm just trying here. No, I'm not an architect, right? So I'm just giving an idea so that you can understand exactly how the things are happening, right? So in the future, if you get a chance to work, right, so you can get understanding, and later you can just enhance your skills on that, right? Architect area, right? So that you can also build some diagram and draw this architecture, big architect, right, for the company, right, just for single sign-on, right? So now you can see you reaches to the PingFederate. Now as I told, right, PingFederate is a centralized authentication product, right? So PingFederate has to connect to different servers, right? So I'll just make something like a big box here, yeah. So you can just imagine this is a kind of directory server, okay? So here you have some Active Directory, you have maybe Oracle Directory server, right? Anything, right, like that. Directory server where basically where user profile is there, right? Wait, I make a mistake here. Just like your notebook, right? How you're just saving the contact numbers. In similar way, you have directory server where user profile is present with the user information, and PingFederate connects to that directory server, right? So PingFed basically connects to this directory server, right, where exactly your authentication is happening, right? So that PingFed can able to handle the authentication, because PingFed is not storing the user the information, right, as I told. So it has to connect to some directory server to get your user authentication done, or to bring the user information to generate the token, right? So PingFed is basically where you are designing the policies, you are designing the authentication mechanism, everything. But for that you need to just connect to some directory server. And when I'm saying directory server, it can be multiple, right? It can be Active Directory, it can be Oracle Directory server, it can be different thing, right? So again here we have the port, right, through which you communicate, and then your authentication will be handled. So you need to configure that in PingFederate. PingFederate has to connect to databases also, okay, like for different purposes again, like take an example, like for OAuth, like in one of the case I have seen that, just a second, yeah, okay, DB, right? It has to connect to some DB database servers also, right? For different purposes, like for OAuth, grant storage, or maybe for if you have some application where the user permissions, roles, or any other profile is present in the databases. So for that also you need to connect, right? So that you can able to handle that user authentication, and also able to bring the user information after authentication, so that you can generate the token and send back to the application, so that yeah, the application can authorize the user and user can able to access the application. Yeah, so this is a kind of thing is flowing in general if you are coming from the internet, right? Now what will happen, like if you can just come through, like yeah, I'm not displaying for the multi-factor. Yeah, for multi-factor also, like you need to connect to some sources, right? Let me put it also here, like multi-factor authentication, right? Maybe any source, any product, right? Maybe ping ID, do product, if you have heard about, right, that Cisco product. So it can maybe multiple, right? Yeah, so for multi-factor also it has to connect, right? So this is a kind of rough idea, like when you are coming from internet. Now when you are coming from intranet, right, from the client network, what will happen here? So I'll make another again user. Where is that user? Let me put it a user here, okay? So take an example. Here we have the user, okay? Here we have the user. Where is that? Yeah, here the user, and I'll mention this user as a client user. I'll mention intranet, okay? You understand that part? Intranet user. That means user is in the client network, in the company network, right? Now if intranet user will try to access something, definitely it has to go to wait, yeah, I'll mention this as let me make it like something here, okay? So here again, like the traffic from intranet user will go to the this is nothing but a DNS, okay? I'll just mention as a private DNS, or you can say as a internal DNS something, okay? Now from private DNS, what will happen here, that is the in the internet, in the company network, I'm saying your traffic will go directly, it will hit to the internal load balance, because you are in the trusted network, right? You're not from coming from the internet. So what will happen here, like let me draw it. So from private DNS you can directly, let me make it something like this, you can directly reach to you can directly hit to this internal load balancer, right? So you can see you are an intranet user, that means you are currently in the company network, in the client network, and then you are just trying to access some federation based application. That means you are directly hitting the private DNS, and from private DNS your traffic is directly routing to the internal load balancer. And once your traffic reaches to the internal load balancer, I think you know what will happen, right? The similar way, right? It can just route your traffic to the PingFederate nodes, and then PingFederate node will able to handle your authentication based on whatever the design they configured in the PingFederate, right? And yeah, it will complete like that. So you can see, right, that's because you are coming from a trusted network, right, a company network. So it's not like you're again going to be a same flow, right? Because yeah, it's just like yeah, like private DNS, that you're in the client network, right, company network. That means yeah, we can allow you to directly reach to the internal load balancer, and then the traffic will route, and then yeah, you can able to access the application, or you can complete your authentication. But whenever you're coming from the internet, then we have some layer, right? Maybe I am not drawing here the firewall, but you have the firewall maybe before coming to the load balancer, right? You have the firewall maybe here whenever the traffic is going from PingFederate to different servers like MFA or directory or database, you have the firewall and some network components here also, right? Which basically just yeah, make the things better, right, in the network area, right? Just make your architecture secure, make your environment infrastructure more secure, more reliable, right? So it's I haven't drawn here the firewall side, but yeah, I'm saying that, right? It definitely you need to place the firewall before the load balancer here, right? So that like you can just stop the malicious request, right? In the firewall also you have some defined rules, right? So you need to configure that in the firewall, so that like whenever the traffic is coming from here, right, it can just block here only, right? It will not allow. So like that. Firewall, let me make it something. Yeah, so something here, right? Maybe it placed here, right? And maybe in this communications here also, right? So it depends, like whenever like your traffic is moving from one place to another, yeah, like we need to make it more secure. So whenever like traffic is moving from Apache to internal load balancer and from internal to PingFederate, I don't see we need a firewall here, right? But whenever traffic is coming from the internet, right, or whenever the traffic is going from PingFederate to another third-party product, right, any third-party server, like, or whether it's Oracle database, whether it's any directory server, I need a kind of firewall there, right, which basically just stop the unmalicious request or maybe any unauthentic request, right? So yeah, this is a kind of diagram you can see everywhere whenever you work in any industry, right? Like whenever because in general we are not exposing our PingFederate over to the internet, right? Because yeah, it's a risky, right? Because PingFed is our server which basically handles the authentication. So we'll not try to expose that over to the internet, rather than we'll just try to create a extra layer of security. As you have seen here, I just put Apache. We can use ping access also, but I haven't drawn. If I go with the ping access, I need to just discuss a little bit more on that, right? So I'm just giving a rough idea. I'm not just describing the entire thing here, right? Because in the ping access, if I talk about ping access, then ping access have different models, right? Gateway model, agent model. In general industry, people use gateway model. So I need to describe you about how the gateway model works, how the gateway, what are the different gateway you design and how that is going to happen, right? So but I'm just trying to give you a rough idea, right? So yeah, if you're coming from the internet, you need to place firewall, you need to just use some routing mechanism, you need to use load balancer so that it can send the traffic to different nodes as per the user reason, right? So that it, like user can so the latency can be reduced, right? It will not take much time to get user to the authentication server, right? And yeah, and then finally you can reach to the internal load balancer or the application load balancer, and then you reach to the PingFederate where exactly your authentication is happening based on the authentication policy design, right? And you have the MFA and directory servers and all those things connected through PingFederate. Depends on again like how is your infrastructure and how is your requirement, right? What type of applications you have, what type of users you have, based on those all things, right? And this is just a basic, and when you work you can see there are more complexities will come, right? Because you need to design some more thing, right? You need to design some flow for the external user, right? External user authentication. So maybe you can just use Azure B2B, right? For that PingFed has to connect to Azure, or if you have some any other use case where PingFed has to work as a broker, right, and connects to Okta or any other product, right, for user authentication. So all these things can come in the design, but again it depends on the application or the environment, right? But I'm just giving you a rough idea, right? So that these are the component we discussed, right, in the PF06, about the firewall, about the network, about the Apache, about the PingFederate, right, about the different backend sources. So all these things you can just see here. I just try to draw, right? I just try to show you. Okay, in the next part we'll discuss about the same thing we'll discuss, but in the cloud, right? For example, this is on-premise completely, right, where we have the control and we are just handling entire thing, right? We have different teams who basically looks on the different things, right? Network, firewall, or the server side, Linux side, or maybe the application. We are basically handling the application, but we have different teams who are basically handling the different things, as you can see in this diagram, right? So in the cloud, like as I discussed in the PF06, so we are going to use the AWS only, and the IaaS model, where you have again the control to see the things, to see how the things are running, yeah, but it will be under AWS, so you will get more advantages, right? You will get more features of that product, which can have yeah, like which can just make your life easy, and you can just monitor things very easily, and yeah, you can run your services also easily. So we'll just try to just discuss that using the diagram. It will be kind of same thing again, because yeah, in the AWS it's not something especially, maybe you can get some new terminology, some name will change, but the things will like the same only. Again, you have the load balancer there also. Again, you can make Apache server also, because your AWS is just giving you the environment, and as we are using IaaS model of cloud, that means we need to just get our machines, right? We just need to install PingFederate, we just need to install Apache or ping access, and we need to design our complete architecture. It's just like the environment I'm getting the AWS, but that means I'm getting the network, I'm getting the firewall, everything I'm getting there. I just need to use that and make that architecture, make that environment ready, right? Whereas in on-premise, I'm not getting the everything in the same place, right? I just need to go and run. I just need to set up my network team. I just need to set up my firewall team. I just need to set up multiple teams, and using that I just need to draw something. I just need to place that something, right, so that my SSO will work. So that's a difference. And yeah, so let's see in the next part 2 we'll discuss about the cloud thing. Thank you.